Hello everybody. So my name is Chris Murphy. I'm an Unreal Engine evangelist. My job is to support developers through Australia, New Zealand, and Southeast Asia. Now, I've been brought out this way because I'm helping out on the Indian front as we're gradually assembling a bit more of a support team within the region. The aim for us is to really be able to help more developers out this way. And while we do that, we've got folks like myself that'll be helping out alongside everyone else. Now, I want to quickly cover a few things today. There are 3 sessions that we'll be running. One is this. The next session is going to be Blueprint 101 with Alex over here. And then the next session after that will be 100 tips and tricks. When it comes to these sessions, there was a slight mistake in our documentation here. Sorry about that. The first session will not require a laptop. So you can take notes if you want, if that's really how you want to do it, totally fine. But the second session is the hands-on session, and the first and third are presentations instead. Okay, so these are kind of going through a wide range of things. Now, this first session is going through just new studio stuff. It's just making sure you're aware of certain tools that are in the engine. It's running through all sorts of common issues that developers face. And then the second session is going to be more hands-on and kind of running you through bits and pieces for Blueprint. And then the third will be tons of little tips and tricks that I've encountered over the years that really speed up your overall workflow. So what this talk is, it's a high-level overview of features within Unreal Engine. Now, that means it's a live demonstration. Like we'll have demonstration of some tools, but beyond that, it's a mixture of beginner and advanced topics, and we're going to start with commonly known tools and then dive a little deeper. Now, before we start, remember what this talk is not, okay? So this is not a full in-depth analysis on a tool-by-tool basis. There's way too much in this engine for me to comfortably cover literally all of it. But it's really important that you understand that we are kind of stepping into some of these things. Now, there's one thing that's going to come up a lot throughout the course of this discussion, and that is going to be Fortnite. So for anyone that's unfamiliar with it, Epic Games make Unreal Engine, but we also make Fortnite. In fact, we make a lot more than just Fortnite. Before this, we had Paragon, we've had Battle Breakers. Back in the day, you had Unreal Tournament, you had Gears of War, you had Jazz Jackrabbit. So, we've always been producing games. And the reason this is really, really important is that we're stress testing our tool set. By constantly building games on our own tools, we have a much better idea about what developers actually need, because we need them too. Anytime these things pop up, we understand what needs to go into our tool set. And this is really, really important since it informs everything. And the reason I specifically wanted to do a call out on Fortnite is that it runs on multiple platforms, all right? So you've got this running on your PC, consoles, and mobile, and all of those devices are the same game. That's one thing that some folks don't realize, is the version of Fortnite that runs on mobile is the same version of the game that runs on PC. Okay, which means that anytime we add features to the PC version, we need to make sure that they run across the board on every platform. We don't have some easy out where we're like, I guess we're just not going to support that. When we add a gameplay feature, it needs to be supported across the board. And it's a pretty big project, which means that there's a lot of eyes on it. We have 250 million players and 10.7 PCUs. So that's quite a lot of developers. But as I said, this means that Unreal is thoroughly tested in the real world by the same team that develops the games. You know what I mean? So this engine is constantly kind of getting beaten down to the ground, and we're working from it. Now, when we're discussing Unreal Engine, I'm just going to quickly throw up a video so you can get an idea of the kinds of projects that have been coming out as of late. one is that you'll notice that not everything in that was games. In fact, not everything in that thing that we just showed off was regular enterprise either. Like we had projects that was spanning from news reports to film to games to architectural visualization to car configurators and all sorts of stuff. Because at the end of the day, this is a real-time engine that's been born from a game development engine. So as far as broad topics are concerned, we're going to be looking at tools and development philosophies that are around. We're going to be looking at C++ and Blueprint, gameplay framework, going into the gameplay ability system, editor tools, build tools, and then we're going to touch on some hypothetical development scenarios and case studies. And that last part there is going to be the real meat of this presentation because that's kind of going through common issues, common concerns from some developers, and hopefully trying to put your mind at ease. Now, one thing I really want to touch on when we look at this presentation is to remember one simple thing, and that is that if you're coming from another engine, I want you to just remember that most of what you probably know isn't specifically engine knowledge, it's game dev knowledge, okay? I bring this up because whenever anyone's moving into Unreal, they're kind of terrified because often they're like, well, I need to start again, right? I need to roll all the way back. But the truth is that like, it's the same as if you were moving from Max to Maya. You know, if you were learning Max this whole time and then you moved into Maya, most of what you were learning was 3D development knowledge. And then when you move into it, you're like, all right, here's the extra stuff, here's the extra layers, here's the little bits and pieces and the shortcuts. But we have this kind of strange misconception from some new developers that are like, so I'm starting from scratch, right? It's not like we're reinventing 3D completely, you know? So just really kind of keep that in mind. Now, when it comes to the tools and development philosophy and what you're really looking at within Unreal Engine, one thing that we really kind of strive for is that the vision holder can implement their vision. And what I mean by this is programming tools for programmers, artist tool for artists, and generalist tools to allow broad access for everyone. And this is kind of fundamental to a few things. Now, the first thing I kind of want to touch on is the elephant in the room. There's a lot of folks that go, well, Unreal's running C++, and that sounds disgusting because I learned that in university and that was terrible. The truth is that there's a lot of macros going on within Unreal. And the reason I bring those up is that that entire custom reflection system basically means that Unreal's C++ doesn't really behave like C++. And because of that, it's a C++ syntax, but you don't really need to handle your own garbage collection. You don't really need to handle a lot of stuff that's going on under the hood because we have all of these macros that if you define like a U function or a U param or a U property, it's just going to grab in boilerplate code and kind of fill this stuff out. And I bring this up because again, honestly, you know, one of those people that like really affects where this is going to go the most is your programmers, your CTOs are going to decide, well, what engine are we using for this? What tool do we need for this job? Now, the next thing I want to quickly touch on as far as the program is concerned is C++ source code access. And this is a really, really, really important detail that I quickly just want to touch into. So when it comes to UE4's code base, the entire engine can be recompiled. If you don't like part of our renderer, you can rip out that part of our renderer. I wouldn't advise it, but you can. Now, but more than that is like when you look at that C++ code base, it's worth noting that we're not just giving you the source code of the current build of Unreal. In fact, what's actually available is if you go to GitHub, you can actually pull down the master revision right now before the new version comes out. Now, what that means is, okay, show of hands in the room of who here has released a game before. A couple of hands going up. Some decided to do this, and they're like, dude, don't single me out. So here's one of the tricks, right? If you don't have source code access to recompile the engine, if you get an engine bug, and, you know, I would love to be able to say that, like, no, it's cool, the engine's bug-free. But no engine is bug-free. You know, we're talking millions of lines of code. Something is going to go wrong somewhere. Or it might even just be that the feature is still being implemented, right? Now, when you've got that much going on, if you were to release, what you can do with our system is if there is a bug fix already, so if you can pull that straight down. So you can access GitHub, and you can say, this is the change list, and I can just bring that one change and fix into my current build, okay? And this means that you don't have to go, oh, well, I guess we're not shipping because the console provider upgraded their SDK version that they require. You can manually bring in that SDK if you choose to. And it's not just that, it's just beyond that, having that access also means that you can take a stab at fixing it. So even if hypothetically Epic don't have a fix up there already, you at least have the ability to fix it. And I would rather have that ability and not need it than need it and not have it. Now, the last little thing that I quickly want to touch on here is that we actually expose all of our Git branches. Now, exposing the Git branches means that if you, let's say you're making a VR game, okay? You can actually access the C++ source branch that is for our VR development team. So you're kind of grabbing that experimental code that hasn't been brought back into our mainline yet. So again, like if you're looking for those fixes, sometimes those fixes can be there and they're all the way out. They still haven't even been brought back into the main line of UE4's code base. So this is really, really important. Now, the next thing I'm going to quickly touch on is blueprints. Hopefully some of you came to the session that we ran yesterday because that was kind of demonstrating the power of blueprints. And this is a really, really, really fundamental element of Unreal in that what blueprints represent is a tool set that anyone on the team can start to be involved in more than just their singular role. And what I mean by that is traditionally you used to have animators just handing off their animations to a programmer and they're like, do it for me. You know, and when you get that kind of situation, you're going to get a programmer doing their best effort to get those animations in. But the truth is it's the animator that has the best idea about what's actually required for those tools. You know, it's the animator that has the best idea of what that's all meant to look like, what all of those crossfade timings should be. And this is where Blueprint comes in because it gives them access to do that. It gives access to your it gives access to your artists to implement their effects. It gives you access to your sound designers to add in all of the cues and boilerplate code to just go off and call their own sound libraries without having to worry about a several $1,000 upgrade, right? Now, for anyone that's unfamiliar with Blueprint, this is kind of what it looks like. So it provides agency to your game designers to not have to worry about the programmers holding the keys to the car. You know, if the programmer doesn't want to drive, that car's not going anywhere. So when you have Blueprint, it allows game designers to experiment, to work with things. And again, I said this yesterday, I don't want the programmers to sound like the villain. So what I was getting at before is that it allows everyone to kind of have more of an input on that project. Now, the most important thing here is to remember one simple thing, and that is that if anyone says, should I be making my game in Blueprint or C++, it's really asking the wrong question, okay? Because these two systems are kind of made to go together. They're made to work with one another. They're made to have your programmers able to build those large-scale, like, underlying systems, and the rest of your game development team really comfortably populate those systems. And that's a really, really important thing, because I get so many newcomers that are like, well, am I just making all of this in C++ or all of this in Blueprint? And it's kind of like saying, you know, am I going to be having food or water for this meal? I'm like, clearly you have these two things together, right? So if we look at this, let's have a quick look at some of the advantages of each of these systems. Now, first off is Blueprint. So Blueprint has some distinct advantages. Faster creation, faster iteration, it's better for flow, and flexible editing, as well as like easier data usage. So it's much easier to kind of drop into a blueprint, change variables, and tinker with things as necessary. C++, on the other hand, has faster runtime performance. It's explicit design, and by that I mean like when exposing variables or functions from C++, you have more control, over exposing precisely what you want and how it's structured. There's broader access. There's more data control overall. Better network replication. I want to be clear. Network replication is built into the engine. However, with C++, you have far more control over, like, if you want to manually pack things in a certain way and that kind of stuff, you can kind of reach into the guts of it all. And of course, because it's code, it's easier to diff and merge. So if you're going to have files, then you're going to have constant iterations from multiple people that are extending those things. That's where C++ comes together. But remember that the two systems are made to work together. Now, more importantly, I want to mention that the best results we see utilize engineer mentorship for your artists and game designers, okay? So if you are getting into Unreal and you are starting to use Blueprint as a system, what I really want to stress here is that it's really, really important internally that you say that these people are the ones that you can talk to about what you're doing. And just every week, just if your artists or your game designers have done any Blueprint, make sure that they just have a short, even sometimes a 10-minute conversation to say, yes, you're doing it right, or, oh, hey, actually, we can use this. Because you got to remember that there's a lot of artists that come into this scripting language that just don't know some of the fundamentals, like right down to not knowing that like a loop is a thing. So explaining some of these things, making sure they're designing things properly, and making sure that it's going to be robust just gives them that little bit of extra knowledge. And over time, this becomes less and less necessary. Now, the first thing that I'm going to touch on as far as the feature set's concerned is the gameplay framework. Now, the gameplay framework is a really fundamental thing, and that is that it's the basic gameplay classes included for functionality for the building blocks of a game. So when I'm going into this, what I'm actually referring to is this, is, as I said before, Epic make games, okay? And because we make games, more and more, we found that we were building certain classes the same way again and again and again and again. So became one of those things that like Epic really pushed to have all of those classes as just core features. You don't have to build them again. And that means that we can pre-optimize a lot of stuff. We can build systems surrounding certain kinds of things. We can automatically handle replication for certain types of classes in different ways based on what they are. And like that kind of implementation is a pretty important thing. Now, I'm bringing it up for a few reasons. One, it's because it's just generally important to know, obviously. But two, is that, again, if you're coming from a different engine where you had to build that structure yourself every time, you've got to remember to not fight that structure. Like coming into Unreal's environment means understanding our structure, why it's there, and you can choose to ignore parts of it till your heart's content. But understanding what's going on and why it's going on, sometimes you're like, no, I want to do it my way. And then you look at this and you'll be like, actually, that's probably going to save me a month. So again, really important thing. Now, the fundamental building block of the the gameplay framework is the actor class. So the actor class is anything that can be placed in the world. It's it handles ticking, life cycle, replication, and destruction automatically. And it's just anything that can handle those 3D transforms. Now, pawns are any actor that can be really kind of given input. That's typically what your pawn is. Now, it's really important to note that pawns also support a concept known as movement components. Now, movement components allow your inputs to control how things are done. So it's really important to look at pawns and controllers and understand what goes on here. So pretend for a second this was a vehicle, okay? Now, as a player, I would be a pawn, okay? And that vehicle would also be a pawn. But we also have another concept known as a controller. Now, you've got to think of a controller as your brain. So what's going to happen is your brain is going to be saying to my body, it's going to be like, move forward. At which point my pawn, my body, then says, all right, I'm moving forward. And as a human being, this is how I walk, okay? Now, if I walked over to my vehicle and I hit use, what would happen is my body would attach itself to this pawn and it would begin to play the get in vehicle animation, at which point my brain would unpossess my body and possess the vehicle. And now the vehicle is going to have its own movement component. And the advantage of the vehicle having its own movement component means that now that I'm in the vehicle, it's going to be able to say, drive forward, drive left, drive right, and it knows that that's how a vehicle handles. But the cool part is that my brain is still just passing in general instructions of like, I want to go that way, at which point the vehicle says that as a car, this is how I move and this is how I do that. So that split in functionality and logic is really important because it means that you can really easily get players kind of moving between all sorts of things and all sorts of elements. So that split there is like a really, really important feature. And as I said, think of the pawns as the bodies and the controllers as the brains. And the cool part there is that it means that controllers can be for players or AI. So you can have player controllers or AI controllers, and the body doesn't care. As far as the body is concerned, it's just being given instructions. And that means that it's very, very easy to just quickly add bots to your game. It's very easy to get something that was meant to be a bot, and as a player, dive into it and control it to check that a setting is working correctly and that some sort of gameplay element is working correctly. You know what I mean? So you can kind of just really easily inhabit different elements of your game for testing purposes or demo purposes, or even just game design tests, right? You know, if you want to say, hey, this game was meant to be like humans against the monsters, what happens if I play as a monster? And if that then just kind of works mostly out of the box, that's like, wow. So the next thing I want to quickly touch on is the character class. Now, before I mentioned that as a character in the world, I would be a pawn, and that was half true. Because what happens is a character is a type of pawn that has all of the base fundamental logic for characters. So anything that would be a standard character class that supports walking, jumping, flying, crouching, networking, as well as custom movement classes. This is a really, really powerful class, and it's what the building blocks of most of your projects are going to be. Who in this room actually came to the presentation that we had yesterday? All right, so there's a fair few of you. So the dragons and the knights, despite seeming completely different things, were both based upon characters to immediately just get all of that functionality working. Now, there's a few other classes, but I'm going to kind of breeze through them, such as your spectator class. The spectator class, again, is just for networking to immediately just drop back to an invisible pawn that can move through the world. We also have a concept known as game mode and game state built in. So your game mode represents your game's logic, and your game state kind of represents the parts of that logic that you want to share between players. So what I mean by that is, imagine that you have a game of capture the flag. The game mode is the part that says, this team scored points, and that only exists on the server. And then the game state class is the one that gets replicated between everyone that holds the current team scores. So if you want and you're not doing a multiplayer game, you can just ignore the game state and just cram everything into the game mode and it's fine. But again, having that structure out of the box means you can get up and running. Now, the player state class is it's a very similar thing. The player states are replicated to everyone. So you can consider a controller, like a player's controller, only exists on the client that it's on and the server. No other machine has access to the brain of your player, okay? Now, because of that, we have the player state class that can still pass information around between every other player, so they can still get specific information about them. And this is useful because you might be like, yeah, but surely you could just stuff that information into the pawn, right? You could, right up until the point that the pawn dies. And if the player dies, you don't want like their score information and things like that dying with them. It's worth noting as well, just there's one last thing while I'm on this topic before moving forward, is that we have camera classes and just a general structure that's already put in so that the second you inhabit any creature or person, it's going to immediately figure out where their eyes should be, and you can override those classes as you see fit. So I wanted to kind of touch on that just because I want anyone that's new, like completely new to Unreal and never opened it up, to understand some of that framework stuff. But the next thing I really want to touch on here is the gameplay abilities framework. Now, the gameplay abilities system is a framework that's very useful for role-playing games and MOBAs, but it can be used in any game with abilities. So it handles your abilities, your tasks, your attributes, your effects, your cues, and it even actually can handle network replication. And for replication, it has the ability to handle client prediction of abilities as well, which allows things to seem far more seamless. Now, this is really, really powerful because what this system essentially is if, I'm not sure if anyone in this room has ever tried to create a game that has like poison damage over time and fire damage over time and health that can be applied and immediately pulled back for different reasons. When you're juggling like all of these different effects that are going into a player and how those things work together and how they can override one another and everything else, that's a problem. Like that's a really difficult task to handle. Now, that task is made even worse when you want to replicate it and have it handling in multiplayer. And that task is made even worse when you want to have your game designers able to easily, functionally go ahead and add that logic to the games themselves without like a skilled programmer. Because what happens is a lot of teams that build the system themselves often go into it and they go, all right, I'm going to roll this myself. And that's okay. All right, it's going to take you a few months and you're going to get there. You might have to build the system a couple of times before you get it right, but you can get there. But the problem is that you're then going to have one person on the team that understands how it works. And that becomes your go-to person that everyone, anytime they need to touch that system, they're just like, it's your job. Because no one else wants to break it. Because things like that can be broken really easily. So having a system that's, again, built into the engine, that's road tested across Fortnite, across Paragon, like those kind of situations is really, really powerful. So when we look at this tool set, it actually allows your game designers to easily add tags and say, this ability does poison damage. And then in other characters, they can say, look, poison damage has this effect and it changes it this way. But they can just pass it around with really, really simplistic gameplay tags. And having them as simple gameplay tags means that you've got a lot more power for your designers to just extend on that system, while you've got a robust, consistent framework that's tried and tested underneath the hood. Now, as far as editor tools are concerned, I'm going to go through some of these reasonably quickly because we do have quite a lot of slides to kind of get through. So as far as editor tools, I'll quickly go through just a couple of things. It's worth noting that for materials, it's a full PBR pipeline. It compiles all those nodes down to HLSL. We have 10 shading models in there at the moment, which is unlit, lit, subsurface, pre-integrated skin, subsurface profile, clear coat, two-sided foliage, hair, cloth, and eye. And as well as that, we support the concept of material instances, which I'll go into a little bit. Now, it's worth noting that this material editor, the reason I actually kind of want to flag it and like go into some of the discussion here is that remember that the material editor in Unreal has existed since UE3, so I want to say 2006. Now, the reason that's noteworthy is that a material editor that's existed since 2006 that has all of the material functions that we've had to write for every single one of our games since then is a pretty robust material editor. Okay? Now, I bring that up because, I mean, like, for perspective's sake, that's like legally able to watch Die Hard in most parts of the world. Like, it's a pretty old system at this point, but it's also a really, really well-tested and, like, well-iterated on system. Now, like having all of that functionality from such a long period of time, it allows like us to have some really, really obscure functionality that's just built into the engine. And that's a really, really powerful thing, not just for using it in your own games, but being able to just open up any of those material functions and examine the node graphs and how they were put together is really, really powerful. And as I said, it all compiles down to HLSL. The pixelation there is kind of killing that, but trust me, it's HLSL. Now, the other thing that we have in there that's worth making use of is material instances. Material instances are a way of you clicking on a material and saying, look, I want a new material, but I just want to override these couple of little bits, which allows you to really quickly have iterations because you can say, look, I want to get a purple version of what I've already got. I want to get a rougher version of what I've already got with this texture applied, or I want to turn this switch on. And there's a lot of features in the material editor that I'm not going to go into, but it does support like per platform diversions. So you can say that, hey, look, if I'm running on this system with this shader model, push it off to here. If it says high quality, use this input. If it says medium quality, use this input. And you can pass all sorts of information around, and the engine's going to automatically compile them down for the correct system. Now, one other little thing that I didn't really go into here and I don't have a screenshot for is it's also worth noting that the material editor as of 4.21 supports per platform stats. Now, what that means is on PC, when it compiles the material in background, it can also compile the material for iOS, for Android, for PlayStation, for Xbox. And in doing so, you can actually see the instruction count on a per platform basis and see what the cost is going to be as you're building it for every other device, not just the one that you're actually on right now, which again is a really, really powerful thing. Now, I'm going to be touching on Foliage Mode just quickly because Foliage Mode is something that has really been getting a big shot in the arm. So earlier this year, Epic Games spun up an open world team, and that open world team's job has been just making those large outdoor worlds better and better and better. Now, Foliage Mode has been a feature that's existed for a long time. Again, this existed in UE3. Essentially, it allows you to just really quickly and easily just paint in stuff into the world, right? You can just use a big old paintbrush, set some density rules, and just paint in. And that's good. But what a lot of developers don't know that's super powerful is procedural foliage. Now, procedural foliage in Unreal is a really, really solid system because what you can do is you can get all of those foliage systems that I just mentioned, and you can set up their growth rules. So you can set up their growth rules and say this thing grows between this size, and it can grow in the shade. But you can say this one can't spawn in the shade. It can't spawn when it's shaded by other trees. You can say that this tree has this many seeds that it disperses, whereas this tree has this many seeds that it disperses in this kind of range. And in doing that, you can just literally turn this system on, and it will go through and it will just plant an entire forest with every piece of foliage that you need, right? You just set up those rules, and they're pretty simplistic to set up. But having those rules set up, the coolest part is that it doesn't just plant you a forest. That by itself, pretty useful. You know what's more useful is that when it plants that forest, it pushes it into the foliage system. And by pushing it into the foliage system, I'm now able to go through it with a paintbrush and just clean it up. So if you're an artist working on a large outdoor environment, you can literally just be like, plant all of the stuff. All right, where's the player going to be? They're going to be in this area. So I'm just going to go through that area and clean it up and tighten it up and have what I want. And in the meantime, all of your trees are clustering in a realistic way. In fact, arguably, there's a good chance that some of those trees are going to cluster in a more realistic way than if an artist was to have been the one to have done it. No offense to artists, but like it's purely from a perspective of those procedural rule sets can often provide a more natural appearance to these things because they split up into the clusters that they would have actually grown in throughout the world. And that's a really, really powerful thing, especially when you can do things like that growth in the shade. I can automatically make it so that I just start growing mushrooms around shaded areas while like these bigger types of plants start growing out in the fields. And this is really, really good. And it's a checkbox. If you want to turn that on, you just need to go to the experimental features section of Unreal. So you go editor preferences, experimental, and just turn it on. At which point you can immediately just drop volumes and create foliage spawners. Now, post-process effects in UE, they're managed by volumes or cameras. So if you want, you can apply post-processing effects directly to the player and just kind of stick it in their own lens. You can also have post-process effects that are just volumes in the world. And we support like a ton of different features. Obviously, you've got your eye adaptation, your filmic tone mappers, your depth of field, screen space reflections, and a lot more. But it's worth noting you can also just run your standard materials from the material editor into your post-process effects and use that as a really great way to do stylized effects. Now, when I'm talking about placing volumes in the world, you can see that I've just created a big old box that we're standing in. And when we're inside of that box, I can then change it so that within this region, this is what we're going to see for the bloom settings. And if I was to take a stroll down through all of these boxes, you can see that they're all going to have different settings for how they fade in, how they fade out, how priority systems work, and where all of that stuff lies. Now, the next one I quickly want to touch on is mesh reduction. So mesh reduction is a system that's been built into Unreal for a little while now, but we only got some part of this done, the skeletal mesh reduction, done in, I want to say 4.2.2. So how this works is really simple. You get a static mesh, and you can actually set up rules, and the engine will automatically go through and just crunch down that mesh and just reduce its poly count. It looks at it and it assesses what it would look like from this distance and then just removes the polys that are going to like change that silhouette the least. And like if we look at it, now this is the worst example piece that I could have used, so my apologies, but it's switching from a 25,000 poly version to literally just opening it up and changing it to a 5,000 and everything else. Now, the cool system here is that you can actually set up rule sets. So you can create your own things, like you could create a group called level architecture. And then just any 3D model in the world, you can then just literally go through it and say, if it's level architecture, apply this rule set, automatically generate that, and just move on with your life. Because again, this means that your 3D artists aren't focused on making all of the different distance versions for these things, because it's kind of a waste of time. You know, like if you have talented artists, you want talented artists doing the hard part. You know, that they should be producing that high quality thing that looks great, works well. And then when you have to go to them and we're like, I need you to clean this up and create a version that's visible from this size, it's just kind of a waste of talent. And it's worth noting that like you can set up your own custom groups. So if your game has very specific items with very specific rule sets, you can comfortably just walk in there and say, look, for this version of the asset, I wanted to do this thing. And for this version of the asset, I wanted to load down this thing. So, you know, it creates 3 for this. And for foliage, it might just create like a close one, a near, and then a super distant one and just drop back to that immediately. But like being able to set those rule sets means that it's literally just a case of when importing, say what it is and move on with your life. Now, I brought up the static meshes, but it's worth noting that here we have a character that's 41,000 polys. Now, if you were to look at the LODs that this is about to generate, so I'm just going to go here and click Apply Changes. If you were to look at the LODs that this generates on these characters, you'd probably look at the base LOD and say, well, this system is terrible because LOD 5 looks like this. Correct. However, that 40,000, we're at LOD 0, we're at LOD 1 at 10,000, we're at LOD 2 at 5,000, LOD 3 at 2,000, LOD 4 at 1,000, and finally LOD 5. There we go, at 600 tries. So like, yes, that LOD from a distance looked like, when you look at it up close, you're like, it's good from afar, but far from good. So having that that system though is like, we don't care about it, like as in we don't have to care about this version. We care about this version, and if you want to, you can go through and set up your own custom LODs. If you don't like the automated system, you can go nuts and just do what you want on that system. But it's much easier to just have an automated, integrated system that goes through and just cleans up everything we're doing. Now, on that note though, we have another system in place called HLODs. Now, HLODs are a really, really powerful little system. We use this a lot in Fortnite. So how HLODs work is basically you can get a big old volume and drop it around a collection of meshes. And what we do is when we drop it around a collection of meshes, it actually just creates a simplified version of the mesh as to what that whole group would look like from a distance. Now, what that means is that, so in Fortnite, you jump out of a battle bus, and as you fall down to the world, you can see the whole island, okay? Now, when you can see the whole island, that shouldn't be something that runs on a phone. That's pretty complicated stuff, right? That's a lot of polys. But how we do it is every single town can now just have an HLOD dropped around it, and it will just, every one of those towns is a simple mesh. And then as we get closer to the town, the engine with HLODs automatically says, oh, hey, they're getting close, and swap out the town for just the regular LODs of those and like the blueprints and everything else. And then so this allows us to kind of move through the world and easily just have like simple distance meshes. And again, it's just one of those systems you don't really need to care about. Now, it is worth noting, the one downside to HLODs is that HLODs require you to build them. And when I say build them, I don't mean like build them. I mean build them in the sense of like you've got to hit the button and kind of wait for it to happen. So quite often what you do is you refresh your HLODs overnight. So you kind of just have yesterday's HLODs as previews for those distances, and then you can pull into it. And you can just build it on the fly that day if you want to. But it can take a little while sometimes to build. But still, it's going to take less time to auto-generate, and it's going to be more accurate consistently if this machine is doing it every day, instead of an artist having to like really carefully manage that thing. And it takes one artist to not realize that a game designer moved the building across, and all of a sudden you would normally have a distance LOD that no longer matches your regular LOD, right? So when you're able to kind of get that system in place where it's just auto-generating and handling it itself, it's going to be more reliable, and that's really, really powerful. Now, as far as visual effects systems are concerned, we have 2 systems. So this is kind of a little bit of an awkward in-between period right now. First off, we have Cascade. So Cascade is the standard effects system that we've had for quite a long time, and it's a really, really good system. Cascade has been like well proven, and it's existed since UE3, right? But Cascade was very much made for game effects. So it does your explosions really well, it does your smoke really well, it does your fire really well, and your sparks really well, and everything else, right? But the difference is that Niagara is a full particle scripting tool that allows much, much, much more control. And what happened is in Cascade, if you ever reached the limit of Cascade, you would have to just go, well, I guess that's how it is now, and you'd have to just live with that. What's really cool though is Niagara allows you to just create your own modules that go into this system, and just spin them up and create additional functionality that was never meant to be there. For instance, this is one that I was building yesterday. And this system here is several million particles. And it's several million particles that's actually being generated from a dynamic camera out the window. And as the camera flies around, it's recreating the entire world beneath it in particles. The cool thing is that takes about 20 minutes. 15 if I'm not explaining it as I'm making it. So like that kind of power is really wonderful, because what Niagara starts to do is it starts to open up tool sets that developers are just not really used to being able to do. Like how many times have you played a game that had a hologram, and that hologram was like a bunch of semi-transparent cubes stacked on top of one another with some science fiction sound effects? And you're like, because that is the standard thing, because the artists were somewhat restricted by the tool sets that they had. So again, I'm just going to step through. So the next one is UMG. So UMG is Unreal Engine's UI editor tool. So you can use this for doing all of your standard UIs, and it's just drag and drop. So you can just drop in buttons, drop in lists, drop in text, and just enter stuff in, right? It's just a standard, like what you see is what you get type of UI editor. Now I bring this up, but what's more important than this is actually that not only is UMG great because it's gives standard your UI developers can actually be the ones who are doing the programming and the art potentially. But we actually have a feature known as editor utilities. Now, editor utilities is wonderful because what it actually does, actually, I might open up a separate image video for this one. What editor utilities actually lets you do, and when I say generate their own tools, I mean that image that you can see in the top right there looks like this. Sorry, I was meant to have included this slide in the presentation, and I forgot. So that tool that you can see there actually looks like this. So any of those buttons that I'm pressing in the top right, I'm kind of clicking around. That's a full procedural landscape generation tool, right? You can click anywhere, you can drop stuff down, you can generate it. It's pushing out the dirt, it's pushing out the grass and everything else. But here's the cool part. That entire tool doesn't require a single line of code. That entire tool is completely done with the UI editor where I just dragged in some buttons and then I just threw in some blueprint. And like, working out how to do that only took a couple of hours, and I know the UI in that version is kind of ugly. But here's the thing: is like when you're able to generate those tools, you're no longer kind of sitting in a system whereby you're no longer having to deal with a system where you can make small quality of life tools. Like traditionally, if you were to go to a programmer and say, "I really want this tool to do this feature," you would have to have a pretty good reason, right? Programmers are grumpy. So, if you're going to go to them and be like, look, can you spend a couple of days to build this thing for me? They have to have a really good motivation. Is like, is that going to save several days, blah, blah, blah. Now, the cool thing of this is that you can really quickly and easily just generate your own subtools to do whatever you want in any industry it may be. Like I could generate a tool that's a really quick, just automatic lighting setup tool, one click, and it just puts in all of the actors for my standard outdoor lighting. Or I could make another tool that says, hey, show me where all of the current guards are in the game, and let me just do like a click, 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 click to lay down their pathing structures and their pathing regions. Like I could generate anything I want, but because it's all UMG, it doesn't have to be done by a programmer. It can be done by the game designers, and they can iterate them, and you can just end up with a library of just small stuff that really, really, really helps your life. I know I'm kind of hitting on that one hard, but like editor utilities, like I've seen people recreate their own entire editors with like scrubbing tools inside of editor utilities. I kind of cried at the time, but it was there's some really good stuff there. So the next thing I really want to touch on here is Sequencer. Sequencer is Unreal Engine's cinematic tool. This is really, really powerful. You can kind of go through, you can do multiple takes on things, you can trigger events, you can trigger blueprints, you can have all sorts of stuff tied into it, and it's a really, really powerful tool. But what's one of the really nice features that we've started to add to this is that you can actually export your own custom passes from it. So if you're actually using Unreal as a renderer for non-games purposes, you can push out different passes of what you've got and use that information for compositing. The other cool thing is Sequencer allows you to modify animation blueprints. This is the last of the editor tools. I'm nearly through it, so my apologies, this took so long. But when I say animation blueprints, what I'm referring to is like in Unreal, we can set up full state machines and have everything structured, right? But what's really cool is Sequencer can reach into an animation blueprint and change those variables. So your cinematic tool could say, look, the person's moving from here to here. And your animation blueprint can say, look, they're currently in an agitated state, so they're going to play the agitated run animation when they're moving between them. And Sequencer could then curve out of the agitated state into, no, it's cool now. And all of a sudden they would like chill out and start walking. But it means that having those two systems working together and like tightly coupled rather than having some third-party plugin downloaded to control it allows for that tight integration where those features, like you only need to animate so much in Sequencer and you can allow the natural game animation system to just do the rest because that's obviously what you want. It's worth noting as well that Sequencer can do some really cool stuff, like it can spawn objects into the world. So if you had a cinematic that like spawned a bunch of rockets, those rockets could persist after the cinematic is closed down. So it's a great way to like spawn in boss fights potentially, or you could use it to actually possess existing stuff in the world. So you could possess the existing player and then push a bunch of animations through them, and then when the sequence ends, they resume control of that player. So you can have like again like a really nicely like integrated system. Now, as far as other frameworks and build tools are concerned, there's a bunch of these to kind of step through. The first of these is like, as far as other subsystems, is the AI system. So the AI system is built up of a few different systems working with one another. We have perception, which allows you to simply slap on a component that is perception. And perception allows you to have sight, hearing, touch, damage sensing, prediction, and team sensing. And then feed that information through really easily. It's worth noting as well that the perception system has some really cool stuff. Like you can say, hey, have a memory of targets for this long. Therefore, like if I'm aiming at them and then they disappear behind a tree, they're no longer perceived and no longer existing. The game will now, like the AI will still know that they're behind that tree or they're roughly in that area. Behavior trees is another really big one. So behavior trees are used to just really easily kind of lay down like structures. The environmental query system and pathfinding for just your standard navigation meshes are big ones. So I'm going to run through a couple of these now. So your behavior trees is like an elegant system for allowing game designers to easily modify and tweak AI, but without really getting their hands dirty in C++ or Blueprint. So it looks like this. Now, it's a little tough to read from there, I imagine, but essentially what happens is you can easily say, look, in this state, do this and then do this. If you can't do this, fall back and do this. Only allow them to enter this state if this variable is set. Only allow them to enter this state if this variable and this variable is set. And you can also do, we have like interrupts. What's the interrupt system called? I've suddenly gone blank on the correct word. So I'm just going to call it an interrupt, but that's not the actual word. I'm going to think of it in a second. Essentially what you can do is you can say, hey, if this variable ever changes, break out of every subtree and then reassess everything from this point. Or if this variable ever changes, again, break out and reassess everything to this point. So you can then like, you could have an attack state, but the second that the enemy like is guarding themselves, it reevaluates everything within the attack state to figure out which is now the best attack based on the kind of defense they're doing. You know, like that kind of stuff is really, really cool. And it's worth noting that like these behavior trees are fully available in Robo Recall. So if you want to actually open up a AAA ship title and examine how the AI have been put together, that's a really, really powerful thing. As far as the environmental query system that I mentioned, anyone that was in the class that I ran yesterday would have seen this. EQS essentially goes ahead and it runs a series of points around the player, and then it assesses all of those points to determine like a score, and then feed that information back to the AI. So in this case, there's a bad dude here, and there is a potential player here. And what I've done is a really quick assessment is saying, hey, filter out everything that the bad guy can't see, and make those valid places. And this is immediately going to let my player find a hiding spot. The cool thing with that, though, is that you can do it from different heights. So I could say, hey, look, can something from chest height see the enemy player? And it's like, no. And then I can be like, what about my eyesight? And it'll be like, yes. And that would immediately give me cover. Yeah, but that's got a different thing. Abort layer priority is the thing. There's a name for that whole system. So anyway, so what that system would do, where I had that chest and eye height, is that it would immediately find me cover in the world. So I could like really cleanly have that without having to waste my time laying down really specific cover nodes. And you could still do cover nodes and just include them in the query, you know? So you could still do that and have a mixture of like dynamic cover and like architected cover, if you know what I mean, like carefully hand-placed cover. Because in my behavior tree, I could be like, look, is there any good hand-placed cover? And it'll be like, oh. And you're like, all right, fall back on EQS and find something that's still vaguely going to work and look realistic so that my AI doesn't look stupid. As far as networking is concerned, so networking in Unreal follows a standard client-server model for dedicated and listening. We support reliable and unreliable replicated calls. We have multicast events, replication of variables, rep notifies, conditional replication. So, if this is the case, replicate this. Relevancy checks, rate limiting, quantization, and custom serialization. And it's worth noting that, before I mentioned that, whenever a game is in development, extra things come in. So the networking model's actually been, it's really been improved by this, which is we actually have a feature that came in because of Fortnite, which is the replication graph. Now, the replication graph allows a programmer to bucket actors and then control their update frequency. So what's really good about that is that if we were playing a game, that green player doesn't need to know about the red players. So the dedicated server just doesn't pass red player information to the green player because they're not relevant. And this is great for a few reasons. One, it obviously reduces overall overhead in network traffic because we're just not telling them about anyone they don't need to know about. But two, is if you're not telling a player about things they don't need to know about, it's much harder to cheat. Because if they're using X-ray vision and you're just you don't know about them yet, then they can't use a cheat to actually see the other player coming through the wall. You know what I mean? There's actually extended benefits of having that kind of system built in there. And as far as the benefits of that, it reduces your complexity for the programmer. So having a networking system that was built in from the beginning, that's an underlying feature of the engine, just overall, everyone that you ever bring into the team knows how it's constructed. Everyone that you ever bring into the team knows how the basic building blocks work together. And we're constantly adding new features because of the very games that we're producing. So this networking layer is getting better and better and more road tested. Next quick little thing I want to touch on is Splitscreen is another subsystem that's built in that runs on that gameplay framework. So Splitscreen literally allows you to add split-screen player support in, how long is this video? I think 15 seconds. In Blueprint, you can just really quickly drum this up because by having that whole framework that just already exists, that knows that pawns need to be done and knows that, hey, we're spawning a new player, so give them a controller and then auto-possess a default pawn specified by your game mode. All of that stuff just being there allows you to immediately just spin up things like split screen. Now, one thing I kind of want to touch on when it comes to split screen is that this is a really good way to actually test multiplayer without building multiplayer. So if you actually have a game jam idea that you want to kick around and you're not sure whether you want to build in all of that networking code just yet, being able to literally just spin up a split screen version of the game to just see if it feels fun when you're playing that with another player can be a really quick way of determining whether it's actually worth kind of doing that whole time investment. As far as the networking is concerned, the other thing that's worth bringing up is the online subsystem. So this is a single multi-platform framework that we use that interfaces with whatever platform you're currently running on. So the OSS allows you to basically say, hey, look, we're going to build an achievement system, right? So we're going to build in all of our achievements, and it just spits out to the OSS and says, hey, give the player an achievement. And what happens is if they're running on Xbox, it does the Xbox query. If they're running on PlayStation, it'll do the PlayStation. If it does Nintendo, it'll do Nintendo. If it's on the Epic Game Store, so any of these systems will spit back and pass out achievements and do whatever they need to do. So Steam can handle itself, PlayStation can handle itself, and everything else can. And as a developer, you only need to care about building it once. And that's really, really powerful. So officially supported platforms are Amazon, Android, Facebook, iOS, Google, Game Circle, Google Play, Oculus, PlayStation, Steam, Nintendo Switch, Tencent, Twitch, and Xbox. And you can create your own online subsystem via plugins. So if you're pushing out to a system that's not supported by Unreal, you can just inherit from our existing OSS framework and just build one that works with your particular store that you're going out to. But it means that if you ever reach out to other markets, you don't need to do some weird stuff to get it working. As far as XR is concerned, so we have all of your standard interfaces for HMDs, controllers, inputs, and all that kind of stuff. Just kind of wanted to quickly just touch on this one since we are currently implementing OpenXR. So OpenXR is currently in the experimental phase. Is anyone in the room a VR developer? Right, there's a couple of you. So OpenXR, for anyone that's unfamiliar with it, essentially is like a standardized interface, which means that, again, you can develop for VR. You don't develop for Oculus, you don't develop for Vive, you don't develop for Index, you just develop for VR, and it does the correct calls depending on what system is plugged in. And the last one here to quickly touch on is just the RHI. So we have a render hardware interface, which is like an abstraction layer for commands for DirectX, Metal, OpenGL, and Vulkan. So this allows you to like really easily kind of fall through different feature levels if you can. So if Shader Model 5 doesn't do this, then Shader Model 4, Shader Model 3, like what features are supported by which platforms, and you can like gracefully just turn things off as necessary. And like having that stuff means that, again, like all of those systems are great because it is very much that implement once with no more fragmentation and like manually supporting different platforms. Now, the new platforms like hopefully will then no longer be a headache. You're kind of building it on top of your existing structures and you don't really need to push for it. The next one I want to go into is localization and internationalization. So localization as a feature is a really, really core part of the engine because again, we make games and it turns out you need to localize games. So this is like a really important thing as far as we're concerned to just have in the engine. And the great thing is we have some really cool structures in there because you've got your basic stuff, right? So you can, straight out of the box, you can say, hey, look, if you've got a string class, if this is actually going to be text being displayed to the player, you no longer have to be a string. You can now flag it and say, this is now text. And if it's text, the engine goes through every single text variable and automatically generates a big old spreadsheet and gets all of the text. And then you can just grab like whatever other language you want to have and just immediately import that to have a translation. But more importantly, that same structure allows you to do asset overrides. The cool thing with doing asset overrides is I could literally have, if I have a main character that's a skeleton and I want to release the game in China, I can now have _ch after the skeleton model. And when you load it in Chinese, it will then load in the non-skeleton so that it's now acceptable. And you could do this for all sorts of stuff. You know, you can do cultural localization, you could do like language localization, and you can bring across assets depending. You could change the flag out front of a house. You could change all sorts of basic little stuff. But by having that system as a very, very simple, like elegant thing built into the engine, like there's no need to reinvent the wheel. This is a really, really, really like important thing for most developers, especially in this part of the world. You know, like you're pushing out to a lot of different people and you want to get as broad a shot on your projects as you possibly can to reach as many people in the audience. So as I said, this kind of like simplifies the overall system. It's built in and it's really, really powerful. One thing to go into just for the programs out there is like we have a tool called the Unreal Header tool and another one called the Unreal Build tool. So this is just for your pre-passes for your header files. So this is what I mentioned earlier. It's just kind of adding all of that boilerplate code in so that you don't have to care about it. As far as other tools that are like the heavy hitters that are really worth touching on, so we have Build Graph. Build Graph is an XML-based scripting system for automated tasks that can optionally run on a build farm. So the cool thing here is you can conditionally push out certain kinds of builds every night and automatically structure them and grab certain things, deploy to certain platforms. The really cool thing is that Build Graph integrates itself with another feature that's publicly available called Unreal Game Sync. Now, Unreal Game Sync is a Perforce extension that we use. Now, what this does, UGS, is essentially it's an add-on for Perforce, and it's a little bit tricky to read, but it can actually distribute builds from Build Graph and then automatically get those binaries. So whenever someone does a code commit, it can then push off to a build server. The build server will automatically compile the engine, grab that code base, and then whenever an artist updates, it will just give the artist the up-to-date binaries without them having to like care about recompiling the engine themselves. The other real cool thing with UGS is it actually supports metadata. Now what that means is, you know when you break the build and you like have to flag a commit as being like an issue, UGS allows you to retroactively go back and say this commit broke this feature and this commit broke this feature. And you can actually flag it so that artists don't update to it. UGS also allows you to see which developers in your team are currently on which versions. So it's really easy to have that communication line and say, hey, when did this break? What's going on? But it's worth noting that that system ties into another one that we released called Gauntlet. Now, Gauntlet is great. It's a testing framework. And what this actually lets you do is really straightforward. Gauntlet allows you to get those builds and automatically deploy them to every single device that you've got, which means every single evening you can get your game automatically from the repo deployed to PC, deployed to Android, deployed to your consoles, and run a series of tests that you've set up yourself provide all of those tests, run through it, get all of the information about where the hitches are, where the performance issues are, and then go, all right, let's put them into a report and send that report back. And the types of tests you can run are pretty great because you can do your standard C++ based unit testing, but you can also do things like screenshot comparisons. So you can literally say, hey, if this level, like these screenshots around the level look 5% different or more, flag it with the art director as something that needs review. You know, and like, again, this kind of system, like I know this is the boring stuff because I'm like, hey, let's talk about automated testing. Won't that be fun? But this is the kind of stuff that like I encounter teams that are spending like they have that one developer whose job is to spend a couple of months building this. And I'm like, it's there. It's free. Why would you not? And like it's a really, really powerful system to have because when it ties in with BuildGraph and it ties in with UGS, this can then spit back those errors that I mentioned before. So we can actually flag to Unreal GameSync saying, hey, this build broke these these specific tests. And the final thing I want to say is that again, by having that entire structure in place, there are obvious benefits, but one of the other really nice things you can do is your QA department has like a really easy, straightforward way of building those tests and automatically doing things like regression testing so that when you fix a bug, the bug stays fixed and you don't accidentally break it again. And just even basic stuff, right? Like every evening, let's check every weapon against every enemy. Can they still theoretically kill the bad guy? Yes. Sweet, we're good. Or no, someone broke the damage on this thing, something is wrong. As far as performance profiling is concerned, there's a bunch of things there that are worth mentioning. We're going to go into, so first off, you've got your stat commands. So this is just executed by a console. You type in like stat and then whatever. So stat game, stat unit graph, stat RHI, stat networking. And that'll kind of just give you a whole lot of information regarding that stuff. Next up is the session front-end profiler. So the profiler that's built in, excuse me, this is like started and stopped with just the phrase stat start file in the console or stat stop file. And it'll just run through and tell you what the CPU is currently doing. And you can kind of filter through that as you want. The GPU visualizer is great. So Control-Shift, comma will load that up, or you can type in profile GPU. It is worth mentioning that if you type in profile GPU into the console, it gives you a lot more information, but the visual indicator is often enough info to get out of that one. Now, one feature that we added in 4.23 is a brand new profiler called Unreal Insights. So this runs in real time. It can run local or over a network. So you can actually patch into other people's machines and see what their performance is currently doing live as the game is playing and understand where the issues are. It displays as a flame graph, so you can kind of like easily break it down for CPU per thread, GPU input, output, and load times. And it displays events across graphs as well. So when you click on a certain frame and you're trying to figure out what went wrong just then and you're trying to track it down, you can actually step into it and say like, well, what log commands went off at the time and what events were triggered at the time, which allows you to kind of narrow down the issues. As far as the network profiler is concerned, again, you can just type in net profile and it'll launch this one up and just tell you network information. I haven't used this one myself, to be honest. I'm usually fixing all of the pretty stuff on a game rather than that. Visualization modes is a really important one. So you can switch into a full screen visualization of like really any of the stuff that's kind of going through the G buffer. But one mode that I really like is this mode called buffer visualization, which gives you all of them at once on screen. The reason I find this one in particular really powerful is that if your scene doesn't look right and you load this up, it's really, really easy to just quickly look at it and go, oh, those things don't match, or those things don't match. Like I was helping a developer recently who had this issue that they had a bunch of characters, and in one particular environment, they had this issue that any character that they had like pale skin had correct sweat. But any character they had that had like darker skin had blue sweat, and they couldn't work out what was going on. Everything was fine in every other level. They were like, what's up? And like it took just like they went through all of their graphs and they're trying to check stuff out and they couldn't quite figure out where the issue was. We opened up the visualization modes and it took about 2 seconds to see what was going on. We could see that anyone that had tan skin was having their reflections created with specular, whereas anyone that had pale skin was having their reflections set with a low roughness value. And like I could see that because on the roughness visualization tool, I could just immediately be like, these two assets look different. And you can just get to the bottom of some of these visual problems. So if you have an asset that's not fitting into the world properly, you're not 100% sure why, this is the kind of stuff that's really useful. Last one to touch on as far as that stuff is concerned is RenderDoc. So RenderDoc is a free standalone open source graphics debugger. There was kind of one of those situations where we were like, why reinvent the wheel? So you can plug RenderDoc straight in and then pull frame specific information and figure out what's going wrong with that specific frame. Now, as far as other noteworthy features are concerned, we're almost up to like the real meat of all of this. I'm sorry, we kind of like went through it. Sorry, I just clicked the wrong button and jumped ahead myself. Good job, team. As far as other networking features are concerned, obviously there's a lot within the renderer itself. You've got your forward renderer, you've got a deferred renderer that's built in, we have distance fields and such built in. Dynamic instancing, so this is a feature that was added in 4.22, but it allows you to automatically just grab batches of assets and it will just render them together. It's worth noting that as of 4.24, so the next build of Unreal that's about to come in, we'll have dynamic instancing working on mobile as well. For dynamic resolution is actually a really cool thing. It looks at your current frame rate, and if your game is starting to lag out, what it actually does, so if your graphics are currently crunching your performance, it actually will get your current frame and it will drop it from like 100% to 50%. Or it'll scale it down and then scale it up based on your current frame rate. Now the advantage of this is we actually keep certain aspects still at full resolution, so we keep doing our anti-aliasing pass at full res, while simultaneously kind of dropping the rest of it so that it doesn't look as muddy. The advantage of this is that, honestly, if your frame rate's suddenly tanking, it's probably because you're in the middle of like a battle or something, right? And if we keep the UI at the same level and we keep the TXAA at the same level, this system allows you to really quickly just scale it down. The second the battle's over, it scales up, and players don't notice. And that allows you to keep a really smooth, consistent, buttery 60 FPS. And as far as the player is concerned, it was always the same quality. You know, they're not looking for pixel imperfections when they're getting shot at with like rocket launchers, right? So you can use that to your advantage and just drop it back automatically. And as I said, like this stuff is just out under the hood, so you don't even really need to set up too much of that. You just need to turn it on. So the next thing here is the multi-user editor is a tool that we've now got built into Unreal. The multi-user editor is really great because this is an experimental feature at the moment, but how it works is you can actually link up your editors now in networking, and as the other person moves one of the rocks, it'll like move it around, and you can have some really, really powerful stuff here because you can run like the VR editor along with this editor and comfortably kind of just move things around. This is really where we see that future being, with developers being able to actually work together in the same environment, mapping things together, and not just kind of committing stuff and hoping that it's good.
Breaking news. Robo-resistance leader Chaos has broken into a Robo-Ready research lab and stolen top-secret military hardware. A recall agent has been dispatched.
Okay, Agent 38, it's Renegade recall time. Oh, nice. Sure you put that one. Good thing it's a bank holiday.
I'm going to dial back the volume. So what you're actually seeing here is some pretty great stuff. Chaos allows for like these large-scale construction. One of the cool things it can do is it can actually run through a network and say, hey, there's too much pressure on this point and this entire thing could collapse. So if you go into a room, you've got like 6 pillars holding up the roof and you take out a few of them, it'll actually like step through it and say, no, and collapse it, even though there's a few still holding them up. We can also do some insane stuff like this, where what we actually do is we can get a entire, we can get something that would normally be running at 1 frame per second and pre-bake the entire collapse, right? And you're probably like, all right, that sounds kind of cool. But here's the cool part, is we can run that simulation of an entire like city block collapsing, and if you were, as a player, were to run through it with a bubble shield or something like that, the second any part of the simulation hits something that wasn't in the simulation, it becomes live. So as far as the player is concerned, every single piece of debris in that collapsing building is legit, because everything around them is, like everything they interact with is interactive, and everything else is just doing what it should. And that kind of system, again, like being built in under the hood, is a really, really powerful thing. That's in beta at the moment. So it's time for us to move on to like whoa, this just jumped into a weird spot. It's time for us to kind of move into those hypothetical areas and look at different scenarios and like how people can move through them. So the first question that we get a lot of is like, well, how do I handle that many assets in large teams? Unreal is very much built to scale, so how do we do it? So first off, use Unreal GameSync, like we'll let you track user changes and whatever else, and it's pretty good at handling binaries that are being passed around. One thing that's worth noting is that RoboMerge is coming into the engine as of 4.2.4. So RoboMerge actually lets you say, hey, here's the current released version of the game, and here's the hotfix, like the next hotfix we're about to release. And then you can say, here is the next major patch, and here is the main master. And if you commit something into the hotfix, RoboMerge will automatically try and put that same change into the next patch and the master. And if you try and put in a feature just into the patch, the hotfix no longer has to have that code change yourself. Do you know what I mean? So like having that system built in that automatically kind of layers commits, it's much easier to run games as a service when the engine is automatically just grabbing those bits that are different and distributing them between different patches where necessary, because it allows all of your developers to say, hey, I'm focusing on some changes for the next major release, or I'm focusing on some changes for right now to put out all of the fires. If you are trying to handle this stuff as far as large teams are concerned, I would strongly recommend C++ usage for high iteration files. So for any of the files that, again, will get a lot of people simultaneously working on stuff, I would tackle that. I would make blueprint classes that inherit from those native base classes and kind of split it out so that your game designers are filling in this area, whereas your native people are kind of working on the underlying structures. I'd also definitely enable the integration of source control into the engine. By enabling source control into the engine, you're going to have far tighter control of all the assets because it will flag which ones are currently good and which ones aren't. And it would also make sure to make use of the inbuilt blueprint diff and merge tool, which allows you to load two blueprints, one from source control and one current, and actually examine the two graphs if you do enter a collision. A feature that's really useful for large teams is called the derived data cache. This is something you can just turn on, and what it actually does is whenever you build materials, you build shaders, it actually saves them onto a network drive. And if anyone else loads the project and they go to build shaders, it actually just checks the network drive first. And it's like, nah, they've already been built, and just copies them straight across. The real strength of this is that if your artists are going through and constantly iterating the materials and doing whatever, they don't make everyone else grumpy. You know what I mean? Like they don't annoy anyone else because they build the materials, and then their version of those materials get kicked off to everyone else, and then everyone can be happy. So the DDC is really, really easy to implement. It involves you like changing one config file, and you can then just share it over the network. Cook on the fly just runs a server that automatically cooks files for a binary build. This can really speed up your iteration times for anything that you're doing and you're trying to get a lot of deployments out constantly. So this is really great for programmers who are iterating on features. They want to kind of like test development binaries, but they don't want to do full builds all the time. As far as platform development specifically is concerned, we have built-in cross-compilers for like Clang, for Linux, and whatever else. As well as of 4.2.3, we added a feature called platform extensions, which is like you can add any support for a platform via a plugin without having to make core major feature changes. But generally, our logic here is very much kind of implement once and build for many. And as far as our currently officially supported platforms are concerned, there's Android, AR, iOS, Linux, SteamOS, macOS, Switch, PlayStation, VR, Windows, and Xbone. Now, one thing that like works on this front is we have scalability settings built into the engine as well. So scalability settings allow you to flag certain assets as like only visible at high detail, only visible at medium detail, and you can preview those differently. The other real advantage of scalability is you can set those scalability settings up on a per material basis. So within each material, you can turn things off, turn things on, etc. One feature that's really useful here, though, is the device profile manager. So if you're building for iOS, the device profile manager allows you to say, might be a little tricky to see here, you can set up like high-end Android, and then you could say, hey, if the device is a Mali device with these with this specific processor, override this setting. Or if it's this thing, override this setting. But otherwise, use everything else in Android and pull that information out as necessary. This as a feature is just really, really useful because it just allows you to override specific devices that are breaking without compromising all of their quality. And because they're still deriving the overall settings from like a base setup, then it means that there's less chance of things going wrong when you iterate other devices and things. You can have that full kind of tree structure going on. Platform stats is what I mentioned before. So you can see here that it will actually show you per platform what the cost is going to be for different types of devices and assess them accordingly. Next question is like a lot of folks like, well, what do you have for mobile? A few things here that are worth mentioning. One is that so obviously Fortnite runs on mobile, and as I said, every feature that we get on PC has to run on mobile as well. Now, one of the big advantages to having this in place is that we have to keep constantly iterating. And we added a feature. Oh, hang on, is this in the slides? Yeah. So we've been adding features constantly to try and speed up our own workflow. Now, because we can't release, a game to the public like this one, we actually went ahead and developed a high-end mobile sample that runs on PC, iOS, and Android called Action RPG. So Action RPG is freely available from the Learn tab. This actually has a lot of stuff, and it is a project very much built to scale. It's really, really over-engineered. We have a lot of features in this. It has your asset management framework built into it. It has the gameplay ability system built into it. It has a whole heap of other stuff, and it scales for different mobile devices accordingly. So you can open this up and check it out as a good point of reference. One other feature I kind of wanted to touch on was Unreal Remote 2. So if you're a developer that's working on mobile, I highly recommend you check out Unreal Remote. It's only available for the App Store, but what it actually does is it will deploy your game. It will stream your game from your PC to your phone. So the second you hit play, it won't even copy any files across. It'll just start playing on your phone. And when it streams across, that means, it's not good for performance testing. But what it's great for is just getting your gameplay up and running. If you're testing your UIs, and you're testing your gameplay, and you need to do that constant iteration, being able to just run your play-in editor that immediately just pops up on your phone is a really, really powerful thing because it just streams it straight across. And a lot of folks are unaware that this exists. Also, it's worth noting that there's a ton of functionality on mobile that's actually turned off by default in the engine. So to turn it on, you just have to open up the plugins menu, do a search for the word mobile. Don't go down to the mobile section. For some reason, some of them aren't under the mobile keyword. Sorry about that. But you'll see that we have a ton of extra stuff that you can turn on. So just from Blueprint or C++, you can now access sound volume, battery level, system temperature, location services, and whatever else you want. So going through that and enabling all of those things, it does give you a lot of stuff. For any developers that are working in VR, the main things that are worth noting here are the VR editor. So the entire engine, you can just run the editor in VR. And that allows you to actually get panels and put details panels next to you as real life panels that you're changing variables on. I'll be honest with you, this seemed really gimmicky to me when I first heard about it. I was like, what? Why is this good? Why are you trying to cram VR into things? What's going on? But then I used it, and I used it on a VR project, and everything made sense because what's really great is when you walk through a doorway, you know exactly how a doorway should feel when you walk through it, like the height and the proportions and the walls and everything else. And from a standard viewport, it might look fine. But when you're actually scaling objects and placing objects in VR, you don't have to iterate by deploying the game to test out the environment and then put the headset on and then take the headset off and make some changes and then put the headset on and change it again. Instead, by building it in the environment, what you're actually able to do is just immediately see what problems you're going to be facing are. And you can just change it and just get it right first time. Again, as well, if you're developing for the Oculus or something, by wearing the headset, you can now just get the lighting conditions perfect for that exact headset while wearing the headset instead of doing it on a monitor and jumping into VR and testing it and then trying it because you want to see it the way it's going to be seen. It's worth noting as well that UE4 has a built-in VR template, so if you are building from scratch, it immediately lets you teleport around, pick stuff up, throw things around. To play a project in VR in Unreal, you literally just click play in VR and it will just launch in. So it's pretty straightforward as a process. Now, if the question is then well, yeah, what about AR? One thing that we've been working on recently was this.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
so we've been working on that. It's the HoloLens 2. And we actually have, we support other AI devices, obviously, but we actually have a new sample coming out for the HoloLens 2 reasonably soon as well. So as far as how do I go about large outdoor environments, again, it's another common question. It's worth noting that a while ago we developed a thing called a boy and his kite. Those are meant to be dimensions. It looks like I forgot to put in those numbers. Sorry. But this was a 2015 demo. It added a ton of features. And you can download this entire project and examine how it's set up. And obviously, we're constantly developing Fortnite, so there's some stuff to kind of get into here. As far as outdoor environmental tips are concerned, so leverage landscapes very heavily. Landscapes automatically allow you to control your poly count as you pull away. They'll tessellate where necessary. There's a really, really useful feature that a lot of folks don't know about called Enable Mask Material Only in Early ZPass. Now, what that actually does is it spends a little bit more time in that early stage of the renderer to work out which pixels are actually going to be visible, and then it only renders those one. Now, this setting, mask material and only ZPass, I've seen it double people's frame rates in outdoor environments, and it's one checkbox, okay? So remember that you can turn things like that on. We also use a feature called Distance Field Ambient Occlusion in Fortnite. So enabling DFAO in your project settings is really, really useful, and making sure that your light is using shadows against distance field at a distance, again, allows you to shade those, shade your forests and everything, even though when they're really, really far away, you still get nice shadows in them without having to have all of the expense of a standard dynamic light. Spline tools for rivers and roads, they're integrated pretty thoroughly. You can just literally draw out a road with a spline. One thing that's worth mentioning on that front is that if you are using these spline tools for rivers and roads, as of 4.2.4, we have a non-destructive workflow, so it's much easier to use them on landscapes and just move stuff and generate stuff automatically. The engine also now has a feature called virtual texturing that's built in. So we have regular virtual texturing, which some of you may already be aware of, but we also have runtime virtual texturing. And runtime virtual texturing gets the entire scene, and basically if it ever renders a text cell on your landscape, it then caches the result and saves it. And what that means is that if your landscape has 1,000 instructions, the next frame that you see that piece of ground, it actually just looks up the values that it's already calculated. So you get a really serious performance boost out of it. This is a feature that just came in beta in 4.2.3, and in 4.2.4 has been brought in as in 4.2.4 was brought in is likely to be in full production. The other thing that's worth going on to here is Quixel Megascans. So recently, Epic Games acquired Quixel. So they're now free for every Unreal Engine user. Your 8K textures, your models, everything from there is completely free for Unreal users. For non-Unreal users in the room, we did make it cheaper for everyone else. I think we made it half the price. Same price, but you get twice as many assets as you previously were. So hopefully everyone's happy on that one. But this is completely free for UE users. So if you're doing a large outdoor environment, you should definitely check out Quixel. Also, just a quick note for anyone in the room, if you've bought Quixel, you can get a full refund for if you bought it in 2019 and you're using Unreal. So you can then just swap the plan over and you'll get a refund for it. Because it's worth noting that Quixel for a big team is $1,000 a month. It's pretty expensive. So it's and when I say big team, I mean if your team makes more than $100,000, it's I think it's $1,000 a month. And if your team is an indie team and it's making under $100,000, it's still $200 a month. So now it's free. Dithered LOD transitions, you can turn this one on. So if you've got that issue where your foliage is popping, you can hit this little checkbox that says enable dithered LOD transitions, and the engine will automatically just make sure that those assets, when you move between things, give it a second, and now when I move forward and backwards, come on, Chris, there we go. It's going to now interpolate between them. So see how you've now just got that nice fade, none of the grass is popping in or popping out, which I think is much nicer. I mentioned runtime virtual textures before. What I didn't mention about them that's wonderful is any other asset is able to look at a runtime virtual texture. So in this case, what I'm doing is I'm painting the ground, but this tree, and I know it's a bit blurry, I'm sorry, this tree is able to look at the texture of the ground. Because it's caching out to somewhere, anything else can examine that same cache, right? And by doing that, what that means is this tree, the dirt at the bottom of it, smoothly will just blend into whatever the landscape material is directly under it, which gets rid of the thing of you can just see that a 3D model has been stuck into the ground, and you're like, I can see the line. Now it's really hard to do it. One other really cool feature of RVTs that's in 4.2.4 is that RVTs now support height. So you can actually get any asset and query how far am I from the ground, and that material will then automatically begin to blend as the asset is put on the ground. So if I get a big rock, it'll get dirty at the bottom, and then as I lower the rock into the ground, it will still be dirty towards wherever it's connecting with the ground and just always fix itself. The world composition tool is a tool that's built in to just automatically generate the world and push it out to like kind of this little mini map style thing. You can then click between sub levels, and this allows you to make massive environments. And we have a feature built into it called origin shifting that does very, very large worlds. Sorry, folks, we're running out of time, so I am kind of shooting through this as fast as possible. I can see the stress on the organizers' faces over here. Now, what if my scene has a lot of people? It's worth noting that the animation sharing plugin is a really powerful little tool. So you can set a master skeletal mesh component that animates, and then slaves from any more kind of copy that master pose. This is really useful because you can just kind of distribute. If you have like 1,000 zombies kind of coming at you, you could kind of render it and just like animate it in a couple of different passes and just kind of push that info in, which is a really, really powerful little thing. We also have a feature for large crowds called animation budget allocation, which allows you to say, I want this much of my frame time spent animating characters. And what that means is all of your up close characters will animate, but then as your frame rate is kind of, if it's potentially starting to dip, what it does is it will then go through and start dropping frames on characters that are farther away, and it's harder to notice that they're jittery. And that works really well, especially like, if you have some sort of 100-player battle royale game. If you've got like collections of people working with the environment, obviously there's like general collaborative level workflow. So you can stack layers on top of one another and treat levels like Photoshop layers. This is a really powerful tool because in games like Paragon, what we did is we had, I think, 6 level layers where they were just stacked on top of one another that would stream in, where we had like your base foliage, we had collision, we had gameplay, we had audio, we had effects, and they were all actually stored in different levels. But the advantage in doing it that way is that if the audio person came in and just modified where all the sounds were, they wouldn't override anyone's changes on any of the other levels who might be modifying game design and other things. I showed you the multi-user editor, which is a thing that we've been actively pushing for at the moment. And like that's really where I see the future kind of covering, because you're going to be in a much nicer spot. So that's it for the core stuff. I have, at the end of the day, we're going to be doing 100 tips and tricks. The last thing that I'm going to spend just 2 minutes more, sorry folks, just before we go into the blueprint is just quickly like what else is Epic. So when it comes to Epic, we have the store, and then we have Epic Online Services. So Epic Online Services is something that was announced in March. It's completely free for all developers, whether you're on Unity or Unreal or CryEngine or whatever you want. It's one SDK for like everything regarding our existing online service framework. It's currently in development. This is, as I said, it's completely free for everyone, and it's kind of leveraging off of all the stuff that we developed for like Fortnite's online server system. So your profile, your voice chat, your parties and matchmaking, achievements, essentially a storage for save games and text chat, all running through one system. And as I said, it's completely free for all engines, all stores, and all platforms. Last little thing on this front is the Epic Mega Grants. So in March this year, we announced $100 million in support for developers doing things in Unreal Engine. Now, this is a really, really cool system because it's no strings attached. We're not taking investment. It's free money. I can't stress that enough. Like if the only real string is if your game gets like, let's say you get 50,000 USD, we'll give you like a chunk of that first, like 20,000. And once you've spent it, you come back and be like, hey, we're still making it. And we'll be like, cool. And then we transfer more money, So it's just we don't give everyone one lump sum at one time. And it's really not about like, we're never going to be like, you promised us 3 characters and you gave us 2. It's more of like, did you stop making the game and go to Tahiti kind of a situation. So, as I said, this is kind of a nice little system, not little, it's a big system, but it is worth noting that it's not just games. So this applies to game developers, media and entertainment, enterprise, education, as well as tool and open source developers. So if you've been developing your own tools that are good for Unreal Engine users, but they're good for everyone else too. So let's say you were making some cool new animation system that allows you to just easily push stuff off. If that helps Unreal developers, even if it's like an extension from Blender or something like that, it still qualifies as something that's potentially able to be like apply for a dev grant. Okay. So keep this in mind. It's very easy to fill it out. You just need to submit a video, a build, ideally, and it's like a couple hundred words. And as I said, free money. As far as further resources are concerned, online training. So the online training platform that we offer is it's hundreds of hours of, that's meant to be a video that's playing. There we go. So each of these is an entire course of many videos, okay? So it's like if you want to learn about believable environments, if you want to learn about post-processing, these are entire courses that are offered completely for free. To get to them, you just need to go to learn.unrealengine.com, okay? Robo Recall, so this is available in the, if in the Epic Store, you go to mod kits, you can look up Robo Recall. If you want to see all of our art assets, all of our blueprint, all of the code that went into that game, and understand how it was put together, that's a really educational thing. Because literally being able to rip up, it's almost the full game. The only thing it doesn't have is the missions. Like being able to open that up is like gold for anyone that's just getting into game development, and gold for anyone that's trying to get an idea of how some of these systems work and how they tie together in a real world. Unreal Tournament is a project that was in development for quite a while. So Unreal Tournament, again, is also available from the Epic Games Store. It's free. You can just download the editor and you can go through and you can just learn a lot from that code base. You know, again, I can't stress enough, like, there's a big difference between looking at a sample and looking at something that is actual shipped product that was in development by a AAA team. Like, that's a huge thing. And speaking of things that were in development by AAA teams, so Paragon was a game that Epic was making quite a while ago, and it was unfortunately put to bed. But when it was canceled, we released $17 million in free assets on the store for free. So if you go to the marketplace and you just look for any of the Epic content, you'll see this there. These are AAA quality characters. It's all of their effects. It's all of their animations. It's almost all of their audio. It's like the non-union audio that's in there. But this is a really, really powerful thing. And even if you don't want to ship a game that has Paragon characters in it, which I understand, it's still a really lovely resource for like examining how these characters get put together and what kind of LOD value, like what kind of poly values we were hitting for different LODs and everything else. Like, can't stress it enough. Content examples is in the Learn tab. This is literally like a museum-style exhibit of every feature in the engine. It's really, really powerful. I mentioned Action RPG before, and Action RPG is the mobile sample that we have, but it also has a really, really excellent breakdown of the gameplay ability system in a single-player context, as well as having like a really, really good documentation to explain why in a project like that we use C++ in some areas and we use Blueprint in others, and give you a bit more understanding as to the context in which those things were used in. All right, sorry we kind of ran a couple of minutes late on that one, but we're now going to be swapping over to Alex for his presentation for the next talk. But otherwise, I hope this has generally been useful for folks. The other two talks that we have going on today are Alex's Blueprint 101, and I'll be doing 100 tips and tricks, which is just like a ridiculous number of just like editor shortcut keys and C++ stuff that people just don't know about. It's pretty useful. So I hope that was generally beneficial to some folks. And in general, I hope you enjoy the rest of IGDC. Thank you very much.